Look at me remembering on my own. So, oh, you can't see it. Thank you. Oh, why didn't it click that? Oh, because I froze it. That's why. There we go. Thank you for that. All right, so functions. Do you remember what grade would you have been in when you first saw a function machine? Have you seen something like this before? A little function machine?
Oh, yeah.
I feel like probably Gigi. There you go. Yeah. Maybe like 4th grade-ish.
I feel like I've seen a penguin.
The penguin. Yeah, totally.
Gigi got me. Margarita.
Oh, I love Gigi. So fun.
I liked it when I understood it. If I didn't understand it, I didn't understand it.
Yeah, it's frustrating because then it's like you can't get past that level, right? Yeah, I know. But I'm always so impressed at how quickly my kids can just, I'm like, what? How do you know that's what you're supposed to do? They're like, I don't know, I just do.
I know, yeah.
Oh, is it? Yeah. Okay. Anyway, I like IXL too. Functions. Shane, I'm seeing the back of your head again. Turn your body. There we go. Functions are going to show up a lot in this chapter, okay? There are things that are what's called a relation, and there are things that are called a function. A function machine is something that looks like this. It's really just a visual to help you think about what is happening with a function, okay? So if I have like y equals x plus 2, or f of x equals x plus 2, we call this function notation. Okay, if you see this, you say f of x. Okay, it's saying the function of x. When I plug in whatever for x, this is what I get out. Now, what I want you to notice is that y and f of x are really the same thing. Your f of x portion is your y in the equation, right? So you have points, an x value and a y value that make a point. That f of x is like the y value of some point, okay? A linear function is a graph that is a straight line. So if you get a graph and it is a straight line, it is a linear function. So like something like this, okay? That would be a linear function. It made a straight line. Now, the only straight line that is not gonna be a linear function is a vertical line, is technically not a linear function because you're not allowed to have any repeating x values, and this has the same x value over and over and over again, okay? But if you can come up with a straight line, you will get a linear function, okay? There's a lot more to it. We're not gonna get super into all of that right now, but I just want you to understand a relation versus a function, okay? A relation can be a function, but a relation doesn't have to be a function. And here's how we tell. If your x is paired with exactly one y, okay, so your input, whatever you put into the function has exactly one y, then it will be a function, okay? What I mean by that is, let's say you have what's called an input and an output, right? You have an x value that you plug into something, and what you get out of it is your y value. So if you look at this function setup, okay, let's say I take the function that we're using right here, y equals x plus 2. Okay, that's our function rule. I take my x value and I add 2 to it. That means if I put in a 6, right, so my input, my x value is a 6. What will my output be? 8, right? I put in a 6, so 6 plus 2 is 8, okay? I put in an x value, I get out a y value. If your x values get you exactly one y value, in other words, there are no repeat x values in your setup, that is a function. If there are repeat x values, it's just a relation. Okay, and every function is a relation as well. but every relation is not a function. It's like every square is a rectangle, but not every rectangle is a square, right? A relation is just relationship between numbers. How are these two numbers related to each other, okay? So I just want to show you a couple examples. These right here, those are relations. If you notice, this x, when I plug in a 1, I got a 6 out, but I also plugged in a 1 and I could get a 10 out of it, okay? That's a relation. That is not a function, okay? If it's going to be a function, every one of my x values needs to be a different number and get a different y, get a y value from it, okay? So notice there are no repeat x's. Okay, now look at this one. Oh, what? That is not a function. Oh, I never changed the numbers.
Did you record?
Shoot. Yeah. Okay, here's what I need you to do. Sorry, I messed up. Call this a 4 and call that a 5. You got to change that.
Wait, what?
In this column of x's, go 1, 2, 3, 4, 5. I meant to change. I copied and pasted over, but then I never changed it. Shoot. I got to change that here. Okay, here's what I want you to see. Are there any repeat, now that we've changed it, are there any repeat x values? No. 1, 2, 3, 4, 5, right? Are there any repeat y values? Yes, that is okay, okay? It is okay to have repeat y values and be a function. Okay, it is not okay to have repeat x values. Have you ever heard of the vertical line test? If you have a graph, so like, you don't have to take notes on this. I'm just trying to clarify some things for you. If I have a graph that looks like this, okay, the vertical line test says if I draw a vertical line anywhere on my graph, vertical line, vertical line, vertical line, if I hit any 2 points on that vertical line, it is not a function, right? So like this one, if I draw a vertical line, I hit every point on that line. That is not a function. But if I go with the red one here, I never hit 2 points at the same time. So if I did something like this, if I do the vertical line test, 1 point, 1 point, no matter where I go, I get 1 point. What do you notice about the y values of that line? The y values stay the same the whole time, okay? So it is okay to have repeat y values. It is not okay to have repeat x values. If I have something like this, okay, this is not a function because if I draw a vertical line, I hit here and I hit here, not a function. You have a repeat x value, okay? So that's kind of one way to help you remember function versus not a function, but basically what you're looking for is, do you have repeat x values? If your x values repeat, it is not a function. It is a relation. If they don't repeat, then it is a function, okay? Also a relation. So here's just kind of a real world example that you can kind of tie into this. It says a person's height based on their age. So if this is age and this is height. Joaquin, how tall are you? How tall are you, Gwen? 5'1". Richie, how tall are you? You don't know? You're going to be tall. Oh, you guys could be close to the same. How tall are you?
Around 6 foot.
Around 6 foot. CK, how tall are you?
5'9".
5'9"? Oh, there we go. Okay. I'm 41. I'm 5'9". Okay. CK is how old? 15. He's 5'9". Okay. Is this currently a function? You can have repeat y values, but not repeat x values, right? Is there anyone else in here that's 14 or 15 years old? How tall are you, Kyle?
Like 5'6".
Is this a function? No, right? they have a repeat X value, two 15-year-olds with different Y values, different heights, okay? So this is a relation. There's just some random relationship between our heights and our ages, okay? It is not going to get you a linear function. It's not going to get you a nice straight line when you graph it, okay? However, if you were looking at how much money you earn if you make $11 an hour, okay? So we're talking about how many hours you work and the money you have earned from it. If I work 1 hour, how much money do I make? $13. You get a $2 tip or what? $11, right? If I work 2 hours, how much money do I get? 22. If I work 3, I get 33, okay? That is a function because there is no number that I could plug in for an X value, my number of hours, to get a different amount of money I make, okay? It's $11 per hour. That is a function. So that's kind of more the real world situation. Age and height are not going to get you a straight line ever because everyone's a different height depending on lots of things, right? Your background, your family heritage, your whatever. There's lots of different things that play into your height. And it can be different for every age, or it can be the same for very different ages, okay? Okay, so does this set of ordered pairs represent a linear function? Now, if I were to graph this, we're just going to freehand a graph because I didn't put a graph in here. If I were to graph this, you're plotting the point 0, 2. Where do you move for the point 0, 2?
To the right, 0.
To the right, 0, and then up 2. So 0, 2 puts me right here. Then we go 1, 4.
Wait, it's not.
Right, you don't even have to see it, huh? Then you go 3, 5. 3, 5. And then you go 1. Oops, I missed. Oh, sorry. My 1, 4 is a struggle. My 1, 4 should have been like here. So then 1, 8 ends up somewhere up here, okay? We said for it to be a linear function, first of all, you cannot have repeat X values for it to be a function. If it's going to be a linear function, it's got to be a straight line. Is that going to make a straight line when you connect those? No. So we would say no, not a straight line. And really, is it a function in general? We would say no, because we also have repeat X values. Okay? So it won't be a function if your X values are repeating. Okay, so here's where we get into like the heart of what you're going to do with this. In the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent the relationship using a table, words, and a graph, okay? Now, it's kind of up to you to come up with what is happening here. And I think laying out a table helps you to see that a lot. So if you look at your setup, starting here, how many rectangles are there in that first one? 1 rectangle, okay? Now think about your perimeter. You can think of it like this would be a 6 and these would both be 1s, right? In that first one, this was a 6 and this was a 1. So I went 1 plus 1. Okay. Try that again. So this is 1. Why are we not writing? 1, 1, 6, and 6, okay? Before I move on to anything, well, let's just do this. What's the perimeter of this rectangle? 14. 1 plus 1 plus 6 plus 6. That's 14, okay? We're going to put other things here, so write this at the very end. So that would get you the point 1, 14. Now look at the second one. There are 2 rectangles there. If I add that all up, 6 plus 6 is 12, 13, 14, 15, 16. Okay, third one. Right, but we got to come up with how that works. So in the third, this is 216. In the third setup, you have 6 plus 6 plus 3 plus 3, which gets you 18. Okay, the idea is, how are we getting there? What is the equation? What is the thing that is happening to get me there? Well, if you look here, I have 2 1s and I have 2 6s, right? For my second set, when there were 2 triangles, rectangles, sorry, the next one's is the next one triangles? Yes, the next one's triangles. When I have 2 rectangles, okay, I still have my 2 6s, right? But now I have 2 sides that are 2. 1, 2, 1, 2. So one side is 2, the other side is 2. In my third one, I have 2 sides that are 3, and I still have my 2 6s. What is not changing in that equation? 2 times 6, right? The 6s are staying the same. So it's basically saying you have 2 times the number of rectangles plus 12, right? Is going to get us there every time. So in 4, it would be, 2 times 4 plus 2 times 6 equals 20. You get the point for 20. Okay? So when they say, give me an equation for this, this is your y. Okay, so I'm going to put it at the beginning because that's usually how we write an equation. Can you turn that into a nice equation for me? If my variable, my x value, is this column right here.
So 2x.
2x plus what? Plus 12. That is the equation that will get you this. That way, if I want to know what would it be for 17 rectangles, now all I have to do is plug a 17 in right there, and I know what it will be for 17 rectangles, right? So that's where equations, functions work out beautifully, is you can do work for down the road from just using the first little batch of information you have, okay? If you're asked to put this in words, and the whole put it in words thing, I'm not as picky about. I would love it if you can come up with an equation. I'm going to ask you to come up with it in words, and I will be a little more gracious about your words because I feel like you could say this differently and still mean the same thing, right? Can anyone try to put that in words? What are you doing? How about, let's start this way. If you multiply the number of rectangles by what?
2.
By 2. Multiply the number of rectangles by 2
And add by 12.
and add 12. You'll get the what? Perimeter. The perimeter. Okay? Okay, and then what you do with the graph is you want to label your x and your y. What would I label this bottom side as? Is this your x or your y, the horizontal? That's your x. That's your number of rectangles. Okay, what's going to go over here? Perimeter. Okay, and I'm just going to do it like this because I think that's how I put it on your review and your quiz. That's your perimeter. Okay, so here's why this comes in handy. If you write it as an ordered pair, it's pretty straightforward to graph it. When you graph, you have to count by consistent numbers, not on both axes, but on any given axis. You can't just go 1, 4, 5, 9, right? We have to go in order. So the number of rectangles, it makes the most sense to count by ones. 1, 2, 3, 4, 5, and so on and so forth. What would be a decent number to count by for your perimeter? 2s would be good because it goes up by 2 each time, right? So you could go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and that would get us all of our points, okay? And then you graph it. 114 puts you right here. 216 puts you right here. 318, 420. Is that a linear function?
Yes.
That makes a straight line if we put a line through that. Questions on that? Okay. I'm just going to do one of these. No, I'm not. Am I? We'll see. We're going to do this first one for sure. Okay, so take a look at this. What are our x values going to be here? Looking at this picture, the number of triangles. So what numbers are we going to plug in? 1, 2, 3, 4. There's one triangle, 2, 3, 4. So 1, 2, 3, 4. Okay. Now you could find your perimeters of these right off the bat if you wanted to, like we did before, right? The perimeter of this first triangle is what? It's 10. 3 plus 3 plus 4, right? The perimeter's 10. Look at your next one. What's the perimeter? So the outside edges, right? That's your perimeter of those two triangles. 14. What's the perimeter of these three? 18 and then 22. Okay, so perimeter is just the outside edges, not every edge. You don't add the ones in the middle, right? You're just saying, what does it add up to on the outside? Okay, now think about what you're seeing here. We did a 4 and 2 3s. Here we did 2 4s and 2 3s. Here we did 3 4s and 2 3s. Here we did 4 4s and 2 3s. What was consistent? The 2 3s, okay? So we were adding 2 3s every time. In other words, we were adding 6 every time, right? You can put plus 6. I just want you to see why it's 6, so I'm going to put it like this. What comes before that? The 4. 4 times what?
X.
Times x. Times how many triangles, right? 4 times 1 triangle versus 4 times 2 triangles versus 4 times 3 triangles or 4 times 4 triangles, right? So my ordered pairs are 1 10, 2 14, 3 18, and 4 22. Okay, if you are a visual person, this is huge. Just being able to see it and see like where are these numbers coming from to see what pattern is happening. Okay, so who can give me an equation for that information? Yes.
4 times x plus 6 equals the number, or
Which is your y, right?
Yeah.
So y equals 4 times the number of triangles plus 6. So that'll be your equation for it. Y equals 4x plus 6. I would say in words, you would say multiply the number of triangles by what?
4.
By 4. And add 6 to get the perimeter. All right. What is going to be my label down here? That is my x value, the number of triangles. Okay, what's going to be the other side? The perimeter. Your y value is your perimeter. Again, what would you count by for your triangles, your number of triangles?
I counted by 2.
For the number of triangles?
1.
I would count by 1 on the number of triangles because we have 1, 2, 3, 4, right?
Yeah, I was doing good.
Yeah, the perimeter you can count by 2s. I would do 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. you don't have to count by twos. You do have to count by something consistent. You could have counted by fours if you wanted. You could have counted by threes if you wanted. It just has to be consistent all the way through, okay? It's easiest if you count by what it's changing by each time because you get nice numbers to work with, but that doesn't always work, so do what you can. So this would be 110. That's this point. 214 is this point. 318 is this one, and 422 is that one. Is that a linear function?
Yes.
You would get a straight line if you put a line through all of that, right? That is a linear function. Okay. I'm going to talk you through this one real fast. I don't know that I do want to show you something about the graph. Let's talk it out. It says the table shows the relationship between the number of photos X that you take and the amount of memory in Y, in megabytes, left on your camera's memory chip. Is it a linear function? Represent using words, an equation, and a graph. Okay. Notice what is happening here. It's going down by the same amount each time. Now, if this is changing by the same amount each time also, you will get a straight line, okay? We'll talk more about that later. That's slope. You've probably seen slope before, right? y2 minus y1, x2 minus x1. Did we talk about that in here already?
No.
No, that was algebra 2. Okay, so with this, if we're trying to come up with an equation, what they're saying is you're starting with 512 megabytes. So I did what to get to here? I subtracted 3. I subtracted 3. I subtracted 3. When this is jumping by 1, that number is part of your equation, okay? So basically what you say is if I take the amount, my y equals the amount I started with. When this is 0, this number will also always be in your equation. Okay, that 0, it's like a y-intercept. It's where it hits the y-axis. It shows up in your equation. So we're going to take that original amount, 512, and then we're subtracting 3 times however many photos we've taken, right? So at 1 photo, I'm subtracting 3 times 1. At 2 photos from here, I subtracted 3 twice. So 3 times 2, or 6. Right? At 3 photos, I've done it 3 times. 3 times 3 is 9. So I took away 9 photos, okay? So this would be the equation that you come up with. Here's what I really need you to understand about that. A 0 is always going to be the standalone number in an equation. And if you are changing by 1, 0, 1, 2, 3, 4, then the amount you're changing by on the other side is what you're going to multiply by your x. -3 times your x. We'll talk more about these as we go, and this can be really tricky for some, and don't stress if it is. We're going to keep working at it and keep trying to figure it out, but that's going to be our setup, okay? If you were to graph it, we would say this is the number of photos. That's your x value. This is your memory, your megabytes. Okay, now this is a little bit tricky. When I try to graph this, what does it make sense to count by for your number of photos? Count by ones. So start at 1, 2, 3, 4, and so on and so forth. Yeah, that's what we're going to do. If you have a number, like these are big numbers, but they're also close together, okay? Here's what you do. You draw a little squiggly like that, and what that means is I'm skipping a whole bunch of numbers, okay? So if you look at what y values would make sense, I'm going to say this is 500, but I'm not going to count by 500s. So as long as you put this little squiggly in, it's saying I'm ditching all those bottom ones and I'm just going to start my graph at 500. Now you can count by whatever you want to count by. What would make sense?
71.
I would count by 3, right? It's changing by 3 each time. So 503, 506, 509, 512, okay? My first one is 0, 512. That's right here. My second one is 1, 509. That's right here. 2, 506, 3, 503. Okay. Is that a linear function?
Yeah.
Yes. Okay, so that's the answer to this question. Is it a linear function? I'm not even gonna put it into words right now. Basically what you're saying is I started with 512 gigabytes and went down by 3 each time I took a picture, something like that. But that's what you're doing with this stuff. Any